physics friends, this video will talk about the subtraction of vectors. This is a very important concept. One vector is subtracted from the other vector. What is the need of this concept in physics? I talked about it already when I started different types of operations as a general review. There I told that we have so many instances in physics such as relative velocity, relative acceleration, displacement. These are few concepts in physics are always expressed in terms of subtraction of one vector from the other. So in general, let us consider a vector A and you take another vector B. B is subtracted from A, that is A minus B vector. But remember, like addition of vectors, you cannot subtract dissimilar vectors. You cannot subtract velocity from the force, displacement from the velocity. You cannot subtract in this way. Displacement, the position can be subtracted from position vector. A velocity vector can be subtracted from another velocity vector. An acceleration vector can be subtracted from another acceleration vector. You cannot subtract velocity from acceleration from position vector. You cannot do that. Therefore, these two vectors we have considered in general are A and B. They are the vectors of similar nature. B is subtracted from A. That can be written as A minus B. Generally, A minus B is vector B is subtracted from vector A. If you write B minus A, it is the vector A minus B is the vector B is subtracted from vector A. B minus A is the vector A is subtracted from vector B. So how to write it? Graphically or in diagram? Graphically you can write, say this is vector A, you take another vector B, the angle between these two vectors that be theta. How to represent A minus B? For this purpose, we can write A minus B can be written as A plus minus B vector. This is the addition of It is the addition of vector A with another vector. This is minus B vector. A plus minus B vector. So how to write it in the board? This is plus B vector and minus B is the negative vector of plus B. You take a vector opposite to B vector and equal in magnitude. This is a negative vector of B vector. This is equal in magnitude, opposite in direction. This minus B vector. Let minus B vector be another vector, say C vector, say. Let it be C vector. Now A plus minus B. So this is this becomes A plus minus B. Instead of minus B, we can write C. So A minus B can be written as A plus C. A minus B can be written as the addition of vector A and vector C. C is the negative of vector B. And you know how to add the vectors. By parallelogram law of vector, you can add these two vectors. We can add by using parallelogram law of vector, and we can get the resultant. So this resultant is, let it be R, let it be R, and using the expression of the parallelogram law of vector, that is A plus B is equal to A square plus B square plus 2AB cos theta. A plus C can be written as this is the resultant vectors. Magnitude can be written as A plus C magnitude. So A square plus C square plus 2AC cos the angle between these two vectors A and C. Let the angle between these two vectors be beta cos beta. Since C is equal to B and C is equal to B, magnitude wise they are equal, and beta is equal to 180 degree minus theta. What are the given parameters? A and B. How to find A and B? How to find A minus B? A minus B is the vector. B is subtracted from vector A. B is subtracted from A. So our aim is to find this quantity. Let it be R. Let it be R. So we need to calculate the subtraction of these two vectors. So the next step we can get the answer. So R is equal to A square instead of C we can write B is B square plus 2AB. Cos beta means cos 180 minus theta is nothing but minus cos theta. So eventually we are getting minus 2AB cos theta, square root of this. So this is the formula we are getting. This is the formula for A minus B. So we can write A minus B, vector minus vector B, the magnitude of this can be written as resultant of vector A and vector minus B. And of course you can calculate the orientation of the vector R with respect to A can be found that yes, phi can be written as tan inverse B sin theta by A minus B cos theta. You can prove it like this. This you can get by putting beta is equal to 180 minus theta and C equal to B in your parallelogram law of vectors, that phi is equal to tan inverse B sin beta, tan inverse B sin beta by tan inverse B sin beta upon A plus or tan inverse C sin beta upon A plus C cos beta. But we have beta equal to 180 minus theta. Sin 180 minus theta is sin theta. Cos 180 minus theta, beta is 180 minus theta, so cos 180 minus theta is equal to minus cos theta. So it will be minus here and C equal to B. So C equal to B. So ultimately we are getting this answer. So when you are asked to find the vector A minus B, B subtracted from A, then its magnitude can be given by the square root of A square plus B square minus 2AB cos theta, and the angle made by this resulting vector R with respect to the vector A is given by the formula phi equal to tan inverse B sin theta upon A minus B cos theta. So we can put it in the parallelogram that this vector is equal to A minus B, and if you put it and slide in this way and put it in this way, then you can find that yes, this is A minus B vector. So one thing you are getting an idea that when vector A and vector B, these are given, this vector is given, B is given, and the theta is given. Three things are given. Then A minus B, its magnitude and its direction you can calculate by using these two formulae. This is also known as parallelogram law of vectors. This is parallelogram law of vector subtraction. Let us now superimpose the law of vector addition and the law of vector subtraction in a parallelogram. In one diagram we can write both addition of two vectors A and B and subtraction. How? Let's see. This is the vector A. It is given. This is vector B. The parallel law of vectors states that when these two vectors are represented by the adjacent sides of a parallelogram, the diagonal which passes through the tails of these two vectors must represent the addition of these two vectors. So this vector, this diagonal represents the vector A plus B. Vector A plus B. Or we can write a little bit down. And we have recently calculated that A minus B will be represented by this diagonal. Sometimes students get confused. It is directed from A minus B is directed from the tip of the B to A or tip of A to the tip of B. If you get confused, you can assume the direction. Let this vector be X vector, and this is a triangle. The sides of a triangle taken in one sense, and the two sides taken in one sense, and two sides taken in one sense. If you are adding, the closing side taken in the reverse order must represent the resultant of these two vectors. B plus X must be equal to A vector. This is vector A. Of course, this is vector P and this is vector A. This is a parallelogram. In this parallelogram, it's quite clear that this diagonal is giving us represents A plus B. And this diagonal represents A minus B and B minus A. But if you take the arrow in this direction, it is A plus A minus B or B minus A. We can see by simple assumption that let us assume that this is the vector X. So B plus X equal A. Then X vector is equal to A minus B. So A vector A minus vector B. This vector is directed from tip of the vector B to the tip of the vector A. So one thing you have to remember, if it is B, if it is A, this is A minus B. And if you take the reverse, this is B minus A. So we can note that the vector A minus B points from the tip of B vector to that of vector A. This is the idea. So the same parallelogram gives us additional vector and subtraction of vector. This diagonal joining the tips of these two vectors A and B gives us the subtraction, and the other diagonal gives us the addition. Let us write the statement that the addition of A and B is represented by the diagonal that passes through the tails of these two vectors A and B. This is about the addition. And the subtraction of A and B is represented by the diagonal that passes through the tails of these two, the heads of these two vectors, the heads of A and B. So if you join the heads, this will give us either A minus B or B minus A, the magnitude, and the other diagonal gives us A plus B. This diagonal gives us A minus B vector. So this is what we call combined parallelogram law of addition and subtraction of two vectors in a single diagram or semi-parallelogram. We can write it in this way. Or you can, if you want to write like this. Law. The following law of vector addition and subtraction of two vectors. You can see here, after writing these two statements of the addition and subtraction of these two vectors given by the same parallelogram, the diagonals represent, this diagonal represents A plus B, this diagonal represents A minus B or B minus A. Whose magnitudes can be given as A plus minus. In one formula I should write A plus minus B is equal to A square plus B square plus minus 2 AB cos theta square root and phi. Here you can write phi 1 and phi 2. Phi 1 is the angle made by vector A plus B, let it be R1 with respect to A, and Then we multiply the vector a minus b, let it be R2 with respect to a. In single formula we can write is tan inverse b sine theta by a plus minus b cos theta. And we can write these two formulae for addition and subtraction of these two vectors a and b. The upper signs, plus sign is for addition and minus sign is for negative sign is for subtraction of these two vectors. Addition of a and b, and the negative signs you will use for subtraction of a and b. This is all about the theories of vector subtraction and addition.